Firstly, on behalf of all the authors, I take this opportunity to thank you for your interest in this work. In this short presentation, I shall summarize the central ideas behind this work, that is teaching a humanoid robot to draw shape. If I was asked to explain the complete paper in one line, I would say that this work introduces the notion of shape into the domain of movement. Shape has been a concept which has often been associated with perception, mainly vision or else other sensory modalities like haptic or so on. For example, shape of a cylinder, shape of a star, shape of anything. What this work does is introduces the idea of shape into the domain of action also, and in this way tries to propose shape as a medium where perception and action meet, and further propose a viewpoint that shape can be a medium through which knowledge of movement can be recycled across skills. So this was the central proposition of this work. To be frank, we rather started off with a playful goal of trying to teach a robot to draw shapes of gradually increasing complexity. For example, start with very simple shapes like I, C, and so on, and move on to more complicated line diagrams and sketches. What we were also looking for was to combine three different streams of learning: action learning through imitation, or learning by observing someone else performing an action in front of you. Also, part of the learning comes from practicing yourself, because you cannot learn everything from observing a teacher. You get a good prototype of a solution, but you have to learn by practicing yourself. And also perform a little bit of mental practice. This is what maybe happens when you are sleeping and dreaming. But the goal was to combine all the three different streams of learning, to acquire knowledge rather quickly, because we all know that humans are very swift in imitating other people, even animals for that instance. The knowledge should be growing and bootstrappable, otherwise we cannot achieve this goal of moving from simple to complex. It should be generalizable, it should be combinable, and to some extent it should be body effector and task independent, because it does not matter if I am writing a U with a pencil in my hand or running a U in a playground. At least the knowledge that I have learned about U-ness should be independent of all these things. So this was the basic goal with which we started this work. Once again, to be frank, we were rather fortunate to have brilliant reviewers who not only analyzed what we said very incisively, but also managed to put their own vision into this work. So what we thought was, assuming iCub has learned to draw shapes of gradually increasing complexity, can it now recycle this knowledge while it learns something else? This is a non-trivial question as to how learning one motor skill can invoke an implicit potential to perceive, mime, or begin to perform many other skills that share a similar structure. And can shape be that medium through which recycling of the knowledge of movement takes place? This question was the objective 2 of this research program. So how do we accomplish the goals we have set ahead of us? The first thing we should observe is that while performing day-to-day movements, the human motor system is synthesizing a wide range of spatio-temporal trajectories. For example, when you try to draw a U or turn a steering wheel, or when iCub tries to maneuver a toy crane, or someone is riding a bicycle or turning a screwdriver, we are basically performing circular or quasi-circular trajectories. So can a robot that has already learned to make a U also have some implicit potential to perform all these other skills, just begin to perform. Of course, the consequences are different because these actions are produced in different context. But can it just have the capability to start performing these actions because of some action that it has learned previously? In other words, if we want to recycle the knowledge of movement, what we suggested was that the trajectory itself is the problem and we need to go beyond trajectory formation. So let us then try to ask, what do we achieve by moving from trajectory to shape? Let us take an example of a trajectory like U. A trajectory is nothing but a sequence of points in space and time in any coordinate frame. By moving from trajectory to shape, we basically can extract the essence of that trajectory, or we can move from U to U-ness. Or what is special to be a U? The special feature in a shape like U is that there is a minima in between two endpoints, or a bump in between two endpoints. It's just a point where the first derivative is 0 and the second derivative is not 0. It can be a maxima or a minima, whatever it is. But the speciality of a shape of this form is that there is a bump in between two endpoints. Now that shape can be of any scale or any orientation or any composition. Like a circle is a composition of 4 bumps, or it can be created by any end effector. I can write a U with my hand or run a U in a playground. The shape representation does not change. So by moving from trajectory to shape, you basically extract the critical essence of that trajectory. Or you move from U to U-ness, or a circle to circularity, or rectangle to rectangularity. Rectangularity is a property of all rectangles, independent of the concerned task. So by basically moving from trajectory to shape, you can liberate the trajectory from task specific details like its scale or orientation or which end effector has created it or so on. So you basically move towards motor knowledge that is context independent. So by moving from trajectory to shape, you can acquire information that is context independent. But this is a perceptual transformation because it is either visually observed or kinesthetically taught, but ultimately from trajectory to shape is a perceptual transformation. What if we ask the inverse question now? Or if iCub learns to synthesize shapes instead of specific trajectories, then it can acquire the graphical grammar to compose a wide range of movements based on context just by mixing shapes. So on one hand you have a perceptual decomposition of a trajectory to shape, and on the other hand you have a motor composition of a shape into trajectory. And in this way you can equip a robot to compose a wide range of movements. It can learn a graphical grammar with a certain amount of fixed shapes. It can perform a wide range of movements. So all it needs to know or learn is the context as to what happens once it performs the movement. But performing the movement itself, it can use its previous knowledge to generate the motor commands. So this was the basic idea behind these two transformations, from trajectory to shape and from shape to trajectory.